In this video I'm going to talk through this addendum section 14.1 where I talk a little more about identities. And throughout we're going to be focusing on this Pythagorean identity. Cosine squared plus tan equals 1, which you should know. You should know by name. It's the Pythagorean identity. What's so important about this is that it tells us how sine and cosine are related to each other. If I know cosine, I can put it into this equation and solve for sine. If I know sine, I can put it into this equation and solve for cosine. If we know one, we can solve for the other one. But there is some fine print here. We need to have a little more information about whether the answer will be positive or negative, because these equations involve squares. So when we're solving, we have to undo a square. When we undo an equation like x squared equals 36, we need to be aware that maybe there's an obvious positive solution, but there's also a negative solution. So the general solution has a plus minus. When we are using this to solve a trig problem, we want to temporarily be open to the idea that there's a positive answer or a negative answer. But probably there will be some other information in the problem that'll let us figure out, do we want the positive answer or the negative answer? So let's do a few quick examples. In this example A, we're saying that theta is in quadrant 1 and cosine theta equals 12/13. So our identity says that cosine squared plus sine squared theta equals 1. If I square this out, I get 144 over 169. I'm going to rewrite 1 with the common denominator anticipating the subtraction. So 169 over 169 minus 144 over 169. I get sine squared of theta equals 25 over 169. So that's the value of sine squared, but I want to know sine. So sine of theta will be plus or minus the square root of 25 over 169. And at this moment, I'm just going to pause, and I'm going to ask myself, which one is it? I'm going to reread the problem. I'm told that theta is in quadrant 1. Oh, well, if theta is in quadrant 1, that means that sine theta is positive. So that information was there. And I can go back here and say, okay, I thought about maybe it's positive, maybe it's negative. But in this case, it's going to be positive, and that square root works out to 5 over 13. This plus sign here is unnecessary. I just left it there to communicate that I thought about the answer and know it's positive. In B, we're told that tangent theta is positive and sine of theta is negative 3/5. Find tangent of theta, but the hint here is to find cosine theta first. If we know sine, we can find cosine. If we find no cosine, we can find sine. Once we know both of them, we can find anything. So cosine squared theta plus sine squared theta is equal to 1. Squaring a negative still comes out positive. I'll write 1 with my common denominator in anticipation of the subtraction. And when I subtract, I get cosine squared theta equals 16 over 25. So cosine theta is positive or negative square root of 16 over 25. And again, I'm going to pause and ask myself which one. Let's reread the problem. Tangent of theta is positive, but sine of theta is negative. Let's just remember, tangent of theta is sine of theta over cosine of theta. A fraction like that would only be positive if top and bottom are both positive, or top and bottom are both negative. Since we know sine of theta is a negative number, that means cosine of theta will also be negative. So we thought about plus or minus, and we realized for this particular example, it must be negative. Negative 4/5. Now, let's remember, we're not done this problem. The instruction was to find tangent of theta. So we know sine of theta is negative 3/5. Cosine of theta is negative 4/5. So when I divide, I get negative 3/5 over negative 4/5. The 5's cancel, the negatives cancel, and our answer is 3/4. So this is our main version of the Pythagorean identity. There are actually other versions, and you're not going to need to memorize these, but you should practice using them. I could give them to you on a test or quiz and just ask you to use them. The other versions involve the other trig functions. So besides sine and cosine, we know there's tangent and cotangent and secant and cosecant. This identity over here tells us how tangent and secant are related. This one over here tells us how cosecant and cotangent are related. And let's just note that they look different. The one is in a different place. So these other ones you don't need to memorize, just use them if they're handed to you. So let's do an example problem. Theta is in quadrant 2, and cotangent of theta is negative 8 over 15. Find the values of all 6 trigonometric functions of theta. So let's just start with our list. Right off the bat, we know cotangent of theta is negative 8/15, which means tangent of theta is the inverse of that, the reciprocal of that, which is negative 15 over 8. Just flip the fraction. Now, if we know cotangent, we can use this identity. So let's do some more work. Cotangent squared plus 1 equals cosecant squared of theta. If I square this out, it's 64 over 225, comes out positive. Let's write 1 with a common denominator. This is cosecant squared theta. So I have 289 over 225 equals cosecant squared theta. So cosecant of theta will be plus or minus the square root of 289 over 225. So we'll pause and we'll think, which one is it? Let's reread the problem. We're told that theta is in quadrant 2. So in quadrant 2, I know that sine of theta is positive. And over here, cosecant is the reciprocal of sine of theta. So if sine is positive, so is cosecant. So we've thought about this, but cosecant will be positive. And this is another one of these examples that's cooked up to be nice. The square root works out to be 17 over 15 without any radicals. So let's transfer that over here. Cosecant of theta is 17 over 15. Cosecant is the reciprocal of sine, so that means sine is 15 over 17. So we're making a lot of progress. The only ones are cosine and secant. To find one of those, we can use another identity, or we can actually just do it by division. So let's point out, we already know tangent of theta and sine of theta. So I'm going to do a little more work down here. Tangent of theta is defined to be sine of theta over cosine of theta. We already know that tangent of theta is negative 15 over 8. And we know that sine of theta is 15 over 17. So what could I do? I could multiply each side by cosine of theta to get that negative 15/8 cosine of theta equals 15 over 17. Then I could divide each side by this fraction, remembering that dividing by a fraction is the same as multiplying by its reciprocal. And it is not a coincidence here that we have 15s that are going to cancel. So this will work out to 8 over negative 17. And typically, we pull the negative out or put it in the top. It's considered very awkward in the bottom. So cosine of theta is negative 8 over 17. This makes sense. We're in quadrant 2, so getting a negative value for cosine makes a lot of sense. And secant of theta is the reciprocal of that, so that would be negative 17 over 8. So this was not easy, but we were able to figure out all 6 of those just from knowing what cotangent was. All right, that is it for this section.